Find the solutions to sine squared of 2 theta equals 1 on the interval 0 to 2 pi. We've got two issues here. First of all, a second degree equation, so we'll need to figure out how to get this down to a first degree sine, and also that we have a double angle. Since the squared term is isolated on the left side, we can start by taking the square root of both sides of this equation. Square root on the left side gets us down to a first degree term, sine of 2 theta. Square root the right side, we need to be careful when we're square rooting both sides of an equation that it can lead to positive or negative answers. So we'll actually be dealing with the two equations, sine 2 theta equals positive 1 and sine 2 theta equals negative 1. Next we have a double angle, so we'll use a substitution that 2 theta equals u. So we'll be looking at solving the equations sine u equals 1 and sine u equals negative 1. And when we do this substitution, we need to be aware that we're solving still for theta, the original variable, and theta was in between 0 and 2 pi. But now that we want to substitute u in place of 2 theta, when we solve for theta, we see that theta equals u over 2. So theta is in between 0 and 2 pi, is substituted with u over 2 is in between 0 and 2 pi. And when we solve for u, we see that u is between 0 and 4 pi. This is what leads us to the rule that when we're substituting for a double angle or triple angle or an angle that has a coefficient, that coefficient also tells us how many rotations we need to find for solutions for u. So we need to find over 2 rotations between 0 and 4 pi. So what are the values where sine u equals 1, u equals pi over 2, vertically on the unit circle. So cosine is 0, sine is positive 1, that is at pi over 2 radians. And since we've done this substitution, we need to think about the second rotation. The point that is coterminal with pi over 2 is 5 pi over 2, the result of adding another rotation of 2 pi radians. And what are the solutions for sine u equals negative 1? That's at 3 pi over 2, and an additional rotation, 2 pi units, puts us at 7 pi over 2. And now that we have solutions for u, we can substitute back in to find what are the solutions for theta. We know that u equals 2 theta, so if we take each of our solutions for u and divide them by 2, we will be able to find theta. So pi over 2 divided by 2 is pi over 4, and this becomes 5 pi over 4. 3 pi over 2 divided by 2 is 3 pi over 4, and this last solution is 7 pi over 4. So we have our 4 solutions to this equation, sine squared 2 theta equals 1.